And let's get started talking about fractions. As I said before, up to this point, we've talked about whole numbers, numbers you can actually count. We've also looked at the idea of the fact that there can be positive numbers and negative numbers. Now we're going to look at what happens if we try to divide things up that are less than a whole thing. You may remember here we had 10 hot dogs divided by into 3 people. But we had 1 hot dog left over. How do we get it? Well, obviously we could fight for it, or we could get a knife and cut that hot dog into 3 pieces so that each person gets 1 piece of the 3. And we say that the person is getting 1/3. How many of you know what that is? Are you good at geography? Those are the Hawaiian Islands. And if I take 5 of them here, I can say that in that box I have 5 of 8 of the Hawaiian Islands, or 5/8. 5 of 8. I'm talking about the notation now. Here I have a group of students divided into 3 groups. If I look at one particular group for one reason or another, the way I can describe that is 1/3 of the class, one group of 3 groups that make the class up. Let's look at how we would put fractions, numbers less than 1, on the number line. What we're really asking about is what fits in here. Let's blow that up. There is 0 on one side, 1 on the other. What can we put in between? Well, if we look dead center in between, we're halfway, where if we go from 0 to the middle, where we've divided the interval into 2. But we can also divide the interval into 4 pieces, so as we go along we have the first piece of 4, the second piece of 4, notice that's equivalent to halfway, the third piece of 4, and finally we're over at the 1. There's 1 piece of 4, and so forth. Now let's split that 1 piece of 4 up. If we're exactly midway between, halfway between 0 and 1/4 is 1/8. We've split the whole thing up into 8. We can chop it even finer and chop that one thing up into 16 parts, and between 0 and where the circle is, we have 1/16 of the whole, 1 piece out of 16 equal pieces. And we can chop finer and finer. We could say 1/16 is equivalent to 2 pieces out of 32. That's equivalent to 4 pieces out of 64, 8 pieces of 128, 16 pieces of 256. So as we chop up into finer and finer things, we can specify more and more minute quantities just by cutting everything in half whenever we get a chance. Let's look at fractions on the number line between 1 and -1. If we go 1/4 of the way toward 1, or we can go 1/4 of the way toward -1. We have negative 1/4, positive 1/4, plus 1/2, minus 1/2, or 3/4 of the way to 1 and negative 3/4 of the way to -1. Negative, positive. Again, numbers increase to the right, decrease to the left. Let's look at another way of looking at fractions. We can divide the whole into equal parts. For example, here I've divided the whole box into 9 pieces, and so each piece is 1/9 of the whole. Here I've divided that whole box into 36 pieces, and each piece is a 36th of the whole. So each part here, each little box, represents a part of the whole that's less than 1 or some fraction of the whole. Let's talk about some terminology. The way you normally talk about a fraction is to say how many parts you have compared to how many parts are in the whole thing. And there's a word for that. The number of parts that you have, the number on the top of the fraction, is called the numerator. That's, for example, if you have 3/5, 3 is the numerator. And the number on the bottom, which says what the total number of equal parts is called the denominator. So in the case of 3/5, 3 would be the numerator, and 5 would be the denominator. We can write a fraction this way. It's a number that can be put into the form a over b, where a and b are any two integers, except again we have to remember that we cannot divide by 0. You can't say I have so many parts of 0. It doesn't work. B cannot be equal to 0. Let's look at how we normally write fractions and then what they mean. One way of writing a fraction, if you want to write it across a line, you'll see this quite a bit because it's easier to type, is 5/8. The more mathematically correct way to write it is 5 with a line and then directly over the 8. It's easier to follow. But typically if you're typing, for example, if you're sending me your homework on a computer, 5/8 will work. And it turns out those two representations are equal to 5 divided by 8, or expressing the division this way. So if you see 5/8 and you want to do math with it, it's actually equivalent to the operation of dividing 5 by 8. When we talk about these things, we say 5/8, 5/8, 5 out of 8, 5 of 8, 5 divided by 8. All of these are equivalent ways to describe the fraction 5/8, where 5 again is the numerator and 8 is the denominator. Let's take a look at a box, and if we split that box in half, we would call that that side that's highlighted in the lighter color 1 piece out of 2. And we would read that as 1/2, one of the most common fractions you'll find. And as I said, it means 1 piece out of 2. Let's look at this. Now I've divided this box into 8 pieces, and there's 1 piece out of 8, 2/8 of the box, 3/8 of the box. So we say that this is 3 pieces out of 8, or 3/8. Let's divide this green box into 9 pieces and look at 1, 2, 3, 4, 5. What I have now is 5 pieces of 9, or 5/9 of that box. Let's look at something that could be a pie. I'll divide that into 4 pieces and then look at 1, 2, 3 of those 4 pieces, and I would describe that as 3/4 of that circle or pie or whatever you want it to represent. Here's a triangle. This one's a little strange, but it works. If I take that triangle in the middle, notice that's equivalent to the other 3. What I can say then is I have 1 piece out of 4. And notice when we talk about that, we're always talking about each piece being identical in size or quantity to all of the others. Now let's look at how we would compare fractions to each other, or equivalent fractions. What is equivalent? We've divided the box in 2 pieces, and we can talk about each piece being 1 part of 2, or 1/2. Let's split the box up again. Same box. Let's split it up now into 4 pieces. If I look at what I have, I can say I have 2 pieces of 4 colored in light, but notice that's exactly equivalent to 1/2. So 2/4 is equivalent to 1/2. I can have half, or I can have 2/4, and I would have the same amount of pi or whatever it is I'm trying to divide. Let's look at splitting that box up even more. I've split the box up into 8. Let me take 4 pieces of the 8 and notice that I still have 1/2 of the box. I can also say I have 2/4 of the box or 4/8 of the box. Notice that those are equivalent, and what's the difference between those fractions? What I have is that if I multiply the numerator and denominator by the same number, I always wind up with fractions with the same value. 6/9 is equivalent to 18/27. I've multiplied the numerator and denominator, the top and bottom, by 3. It's also equivalent to 2/3, and it's equivalent to 20/30. They're equivalent because they're equal. It's really the same number expressed in different ways. For example, we can look at fractions on the number line, going between 0/2, which is 0, 1/2, 2/2 is equal to 1. I can split that up, dividing it into quarters. 1/4, 2/4, which is equal to 1/2, 3/4, and 4/4. I could go even finer. Suppose I start with quarters and then split those up into 8 equivalent pieces. Notice that 1/2 is still halfway across, 2/4, 4 pieces out of 8. I'm talking about exactly the same numbers. 1/4 is equivalent or equal to 2/8. They're equivalent fractions. 3/4 is equivalent to, has exactly the same value as 6/8. Now let's talk about what's less than what in the fraction world. There is that line between 0 and 1 divided into 1/8, 2/8, which is 1/4, and 3/8. Now we can do the same thing negative. Going the other way, we have minus 1/8, minus 2/8, minus 3/8. Numbers increase to the right, numbers decrease to the left. So I can say that 2/8, 1/4, is less than 3/8. And it's backwards. Remember, the more to the left you go, the less the number is worth. Minus or negative 3/8 is less than negative 2/8. Any number to the left is less. Any number to the right is greater. 3/8 is greater than 2/8 because it's to the right. Minus 2/8 is greater than minus 3/8 because it's to the right of it on the number line. Again, any number to the right is greater. Let's talk about upscaling a fraction. Suppose we want to take 3/4 and split that into not 4 pieces but 8 pieces, but keep those ratios the same, so that instead of if I have 3 people, I can give them each a quarter. Suppose instead I want to give them 2/8. Basically, here's what we want to do. To upscale a fraction, I multiply the numerator, the top, and the denominator, the bottom, by the same number. Remember, one number over another is equal to 1, so I'm not changing anything. 3/4 is equal to 6/8, but there may be something I want to do where I need to chop things into 8 pieces, not 4 pieces. So I split each piece in 2. So instead of having a total of 4, I would have a total of 8. And if I have 3 of 4 and I split each of those 3 into 2 pieces, I would have 6 of them. Let's look at the rule for upscaling a fraction. Here we go. All you have to do to upscale a fraction is multiply the numerator and denominator by the same number, and the result is an equivalent fraction with larger numbers. On the other hand, perhaps I want to reduce a fraction. To do that, I just divide the numerator and denominator by the same integer, and the result is an equivalent fraction with smaller numbers. And you can go up or down as you like. For example, 15/27ths, if I divide the 15 by 3 and the 27 by 3, I can change this fraction to 5/9. Exactly the same quantity, just expressed differently, and the difference is a factor in the numerator and denominator. There is a particular factor, the biggest one you can take out, that will reduce a fraction as low as it will go. And that's called reducing a fraction to its lowest terms. In other words, you can't go any further. That fraction is as small, the numbers on the numerator and denominator, as small as you can get them. For example, if I have 4/8, I can operate on that, divide the numerator and denominator, top and bottom, by 2. When I do that, I get 2/4, but I'm not done yet. There's still another 2 I can take out, and finally I'm left with 1/2. I cannot go any further. Therefore, I say I've taken out every common factor between the numerator and denominator. I can't go, there's nothing else I can do. That fraction is reduced to its lowest terms. And in this case, the greatest common factor is a 4, because I was able to divide the 4 by 4 to get 1, and I was able to divide the 8 by 4 to get 2. You don't really have to look for the greatest common factor, because you can just do this stepwise as I've done, and that's actually easier than looking for the biggest chunk you can take out at once. The best strategy is to try to keep going and then look and try to finally get to a point where you say, I can't do this anymore. Let's look at the rule. To reduce a fraction to its lowest terms, you divide the numerator and denominator by the largest integer that divides evenly into both numbers. And you just keep doing this until you say, well, I'm stuck. And if you get it right, you're truly stuck. For example, if you have 72/90ths, you notice that a 9 will divide 72 and it will divide 90. This reduces us to 8/10. But then you look at that, boy, both of those are even. Let me go another factor of 2 here. Now I have 4/5. You ask yourself, is there anything that I can divide evenly into 4 and 5? And you scratch your head for quite a while and you find out there isn't. When you give fractional results on answers, on homework and in exams, unless you're told otherwise, you're going to want to express those answers in the smallest possible fractions you can, the lowest terms. 4/8, that's not reduced. 2/4, no. I can go further than that. I actually have to go to 1/2. You should try to keep dividing out these constant factors until you are stumped, till you can't go any further, for full credit when you do problems with fractions. Let's look at some of the special properties that'll help you to reduce or simplify the fractions. First of all, if you have the same number over on the numerator and denominator, that's equivalent to 1. 1 over 1 if you have 2 parts of 2, or 567 parts of 567, you have one thing. Where n is any number, n over n is equal to 1. Any whole number itself is equal to 1, but be careful, that's not true for 0. It has to be some number greater than 0. Any number over 1 is just that number. So if I have 7 things, each one whole, that's just 7. 273 oneths is just the number 273. Any n, where n is any number, over 1 in the denominator is just equal to that number. Any whole number over 1 is equal to itself. What about 0 over some number? If I have 0 parts divided into one thing, I have nothing. If I have no parts divided, or of 273 things, I have nothing. If I have no parts of any number, I have nothing. 0 divided by any number, not 0. Remember, I cannot divide by 0. N cannot be 0. 0 divided by any number, any fraction that's 0 over something, is equivalently 0. I need to be pretty careful here, because if I have 1 over 0 or any number over 0, it's not defined. It's not a number. We don't even talk about it. We sweep it under the rug. We just say, you can't do that with the math we're dealing with. Let's look at mixed numbers. Often, what you'll have is some number and a little bit more. Let's talk about a proper fraction. We've talked about those now, where the numerator is smaller than the denominator. For example, you might have 3/4 is an example of a proper fraction. An improper fraction, gosh, that sounds terrible. An improper fraction is where the numerator is bigger than the denominator. For example, 4/3. 3/3 is 1, so 4/3 is bigger than 1. When you have fractions like this, what you want to do is change them so you have a whole number and whatever fractional part is left. We talk about a mixed number, and a mixed number contains an integer and a fraction. 2 1/4 is a mixed number because you have the whole number 2 with 1/4 left over. And what that really means is 2 plus 1/4. And there's 2, and there's the 1/4 more. We read this as 2 1/4 or 2 1/4. And what we mean here is it's 2 wholes and 1/4 more of a whole. There's one thing, 2 things, 2 and 1/4. It's 2 plus 1/4, and that's the mixed number. Now, if we wanted to change this into an improper fraction, notice that we can take the whole numbers, divide those into quarters, and then count. What I have is 4/4 from the first one, 4/4 from the second one, and the 1/4 more, or we get the improper fraction 9/4. Here's the rule for changing a mixed number to an improper fraction. You multiply the integer, the whole number, by the denominator, then you add the numerator to what you get, and then that total is the numerator of the improper fraction. And you keep the denominator. For example, I multiply the 4 times a 2 to get 8, add 1 to get 9, and keep the 1/4. 2 1/4 is equal to 9/4. Let's go the other way. Let's change an improper fraction to a mixed number. Here we have 3 3/4, 15/4 if we count them. And what we do is we divide the 15 by the 4 and see that the remainder is 12, remainder 3. Basically, you do a division and look at the remainder and make that into the fraction. Let's look at the rule. You divide the denominator into the numerator and write the answer as a mixed number with the remainder divided by the original divisor. Let's talk about another definition and see what a rational expression is. That's a number that can be put in the form of a fraction, a over b, where a and b are any 2 integers. And of course, b can't be 0. We can see that there are some things that are true for these expressions. For example, if we multiply the numerator and denominator of a rational expression by the same thing, we don't change the value. And similarly, if we divide the numerator and denominator, we also don't change the value. A rational expression is a fraction that contains monomials or polynomials in the numerator or denominator. For example, that is a rational expression because it